Hello, in this video I'm going to talk to you about sphere packing, and specifically packing density, which is also sometimes called packing efficiency. Packing density is the following ratio. It is the volume of the spheres inside of a cube divided by the volume of the cube itself. This is often converted to a percent. So if you worked this out and ended up with a ratio of 0.5, you would then call that 50%. So 50% density or 50% efficiency. We will be looking at three situations: the simple cubic cell, the face-centered cell, FCC, which is sometimes called CCP, and then the body-centered cell, or BCC. In the simple cell, we have this diagram as a model. It's not color like the rest, so I guess I'm coloring it in. What we have is a sphere centered at each vertex of the cube. So there are 8 of these spheres centered. However, they're not 8 whole spheres. They are in the shape of a portion of a sphere. In fact, each one is 1/8 of a sphere. So what we have is 8 1/8 spheres, which makes up one whole sphere. So we have one whole sphere. It's just chopped up into pieces inside that cube. Now, when we're talking ratio to calculate density or efficiency, you might be tempted to say, okay, one sphere in one cube is 1, which is 100% efficiency. Well, clearly that can't be true because we have space inside this box where there's no sphere. So it cannot be 100% efficient. So what's with the contradiction there? Well, it's really no contradiction. It's just me misrepresenting the definition. It's not the number of spheres inside the number of cubes. It's the volume of spheres inside the volume of the cube. So a little bit later on, we'll go to calculating that volume. But clearly, this is all incorrect. All we need to know right now is that there are 8/8 of a sphere, which is one whole sphere inside that cube. In the next diagram, face-centered cell, we still have these 8/8 of a sphere, so that's one whole sphere. But then we also have a half of a sphere here and another half here. Of course, half of a half makes one whole. Then we have a half up here, and then on the back is another one. That's another whole. And then on this side and the bottom, there are 2 more halves. Again, 2 halves makes one whole. So this diagram contains 4 spheres. So 4 spheres in one cube. And then the third diagram, body-centered cell, once again, we have these 8 vertices. Each one is the center of an 1/8 of a sphere. 8/8 is one whole. And then as you can see, inside that cube is another whole sphere. So there are 2 spheres inside that diagram. So those are the 3 situations we're going to look at, and we'll be calculating the volumes and then converting that to the ratio, which we will express as a percent.